There is a photograph taken somewhere in Pennsylvania in the late 1940s that stops people cold the first time they see it. A locomotive is coming straight at the camera at well over 100 miles per hour, its nose a shark-like wedge of polished steel, its body clad in a flowing shroud of riveted metal that seems to belong on the cover of a science fiction magazine rather than on a railroad track. Steam boils away from its sides in great white curtains. The ground trembles, the air shakes, and the men standing beside the track are leaning backwards slightly, instinctively, even though they know the train is not going to leave the rails. That locomotive was the Pennsylvania Railroad T1. It was the fastest steam locomotive ever operated in regular revenue service in the United States. It was almost certainly the most visually stunning machine ever placed on American tracks. It was the last great gamble of the most powerful railroad company in the world, a billion-dollar bet against the future made with fire, steel, and an almost reckless confidence that sheer engineering genius could hold back the tide of time. Every single one was scrapped. Not one survives. The most beautiful locomotive America ever built does not exist anymore in any form other than photographs, film fragments, and the memories of the men who drove it, maintained it, feared it, and ultimately watched it die. This is the story of how that happened. It is a story about ambition and blindness, about the difference between brilliance and wisdom, about what it costs to be magnificent in the wrong moment. It is the story of a machine that was built to save an era and instead became the marker of its end. To understand why the T1 existed, you have to understand what the Pennsylvania Railroad was. By the early 1940s, the Pennsylvania Railroad was not merely a railroad company. It was a sovereign power. It operated more than 10,000 miles of track, employed 250,000 people, and moved more freight and passengers than any other railroad on Earth. Its main line between New York and Chicago was the busiest rail corridor in the world. Its Manhattan Terminal, Pennsylvania Station, was so vast that 4 simultaneous arrivals barely caused a ripple in the flow of travelers moving through its halls. The Pennsylvania Railroad called itself the standard railroad of the world. That was not modesty with an asterisk. The company genuinely believed, with reasonable historical evidence to support the belief, that its engineering methods, its operating practices, and its equipment set the standard that every other railroad on the planet should aspire to meet. Its locomotive design teams were among the most talented in the history of transportation. Its test plant at Altoona, Pennsylvania, could measure the performance of any locomotive to the hundredth of a pound per square inch, producing data so precise it was used by engineering schools as textbook material. This was the organization that decided, in the middle of World War II, that it needed the most powerful, fastest, and most efficient steam locomotive ever conceived. Not just a very good locomotive, the absolute pinnacle. The machine that would prove, once and for all, that steam was not dying, steam was evolving. The war had done strange things to the railroads. On one hand, it had brought them back to life after years of Depression-era decline. Troop movements, war materials, industrial production on an almost incomprehensible scale. All of it flowed through the railroads, and for a brief, exhausting, glorious few years, the trains ran at capacity around the clock without pause. The Pennsylvania Railroad's locomotives were dragging trains so heavy and so frequent that the equipment was being worn down faster than it could be repaired. On the other hand, the war had also accelerated exactly the technologies that would eventually make steam locomotives obsolete. Diesel engines, developed through military aviation and marine applications, were becoming more powerful, more reliable, and cheaper to operate. The General Motors Electromotive division had been quietly perfecting its diesel-electric designs through the 1930s, and by the early 1940s, those machines were beginning to show something that made railroad executives deeply uncomfortable. They were better than steam for long-distance passenger service. Not dramatically better, not obviously better to the untrained eye, but better in the ways that accountants care about. Cheaper to fuel, easier to maintain, ready to run without the hour-long warm-up ritual that every steam locomotive required at the start of each shift. A diesel could be turned off at the end of a run and started again 3 hours later. A steam locomotive required a fire to be maintained, water pressure to be managed, a dozen systems to be monitored constantly even when it was sitting still doing nothing. The men who ran the Pennsylvania Railroad could see this. They were not fools. They understood that the diesel was coming. What they refused to accept was the idea that steam was finished. Their reasoning was not entirely wrong. Steam locomotives, at their best, could still outperform diesels in raw horsepower. They could accelerate heavy trains faster. They could achieve higher top speeds. In the mountains, on grades where sheer pulling power was the only thing that mattered, the best steam designs still had advantages that diesel could not easily match. The question was whether those advantages could be maintained and extended quickly enough to justify continued investment in steam technology, or whether the combination of lower operating costs and simpler maintenance would make diesel the inevitable choice regardless of peak performance figures. The Pennsylvania Railroad decided to answer that question with the most ambitious steam locomotive program in American history. The project that resulted was called the T1. The design challenge handed to the engineering team was extraordinary, even by the standards of a company that routinely did extraordinary things. The new locomotive had to be capable of hauling a 1,000-ton passenger train at a sustained speed of 100 miles per hour on level track. Not briefly, not in favorable conditions. Sustained, reliable, repeatable. 100 miles per hour as a working speed, not a record run. It had to do this with a level of fuel efficiency that would make the comparison with diesel favorable, not just in raw power, but in operating economics. It had to be reliable enough to run scheduled service without the constant, expensive intervention of the maintenance crews that older steam designs demanded. And it had to fit within the physical constraints of the Pennsylvania Railroad's infrastructure, weight limits on bridges, clearance limits in tunnels, the long list of compromises that every designer works against, the invisible walls that surround every engineering project. The solution the engineers arrived at was something called the duplex drive. Most steam locomotives of the era used a single set of driving wheels, connected by a system of rods that synchronized their movement. The power of the steam went into this single system, which worked very well up to a point. The problem was that concentrating enormous power in a single driving mechanism put extreme stress on every component. Rods, couplings, crank pins, all of them were being pushed toward the limits of what materials could endure. The duplex concept divided the driving mechanism into two separate units, each with its own set of cylinders and pistons, positioned one behind the other on the same rigid frame. Instead of 4 cylinders driving one set of wheels, you had 4 cylinders driving 2 separate sets of wheels, with the forces distributed across more contact points. On paper, this allowed the locomotive to develop far more power without overstressing any individual component. The pistons could be smaller, the connecting rods lighter, the overall balance of the machine more refined. The duplex drive was not a new idea. The Baltimore and Ohio Railroad had experimented with it years earlier, with results that were promising but not definitive. The Pennsylvania Railroad looked at those results, concluded that the concept was sound but the execution had been imperfect, and decided that with their superior engineering resources and their Altoona test plant, they could make it work the way it was always supposed to work. What they needed next was someone to make the machine look as extraordinary as it was designed to perform, and for that, they turned to a man who was not a railroad engineer at all. Raymond Loewy was a French-born industrial designer who had emigrated to the United States after the First World War and built a career designing things that made people stop and stare. He had designed refrigerators, automobiles, cigarette packages, department store logos. He approached every project with the same fundamental belief that the way something looked was not separate from the way it worked, that beauty and function were not opposites but reflections of the same underlying intelligence. An object designed with genuine care for its purpose would naturally tend toward elegance, and an object made elegant would tend to work better because the people who used it would treat it with more attention and pride. Loewy had already worked with the Pennsylvania Railroad, redesigning one of their earlier locomotives into something that passengers and journalists photographed everywhere it went. Now they gave him the T1, and he produced something that people still argue is the most beautiful machine America ever put on rails. The T1 was sheathed in a smooth, sweeping shroud of sheet metal that flowed from the bullet-shaped nose back over the boiler and down to the running boards in a single, unbroken line. The nose was sharply angled, shark-like, the kind of shape that a child draws when asked to draw the fastest thing they can imagine. The sides curved inward and then flared out again, suggesting speed even when the locomotive was standing still. The colors Loewy chose were simple and severe, Brunswick green or Tuscan red depending on the period and the assignment, with gold striping that caught the light and seemed to move even when everything else was stationary. Standing beside a T1 at rest in a station, you felt the future pressing against you from the other side of the metal. Standing beside it when it was in motion was something else entirely. People who witnessed it described something close to physical vertigo, a sensation not just of speed but of time itself being compressed and pushed aside. The first 2 prototypes emerged from the Baldwin Locomotive Works in 1942. The Pennsylvania Railroad ran them through an extensive series of trials, pushing them hard on the main line, measuring every variable with the clinical precision that Altoona made possible. The results, initially, were extraordinary. In test after test, the T1 demonstrated that the promises made on paper were achievable in the real world. The duplex drive delivered its predicted power without the mechanical stress that had doomed earlier attempts. The locomotive accelerated with a smoothness that was startling in a steam machine of its size. The top speed numbers were simply staggering. On one famous test run in 1946, a T1 was clocked at a sustained speed of 112 miles per hour, hauling a full passenger train over a stretch of level Pennsylvania track. 112 miles per hour in a steam locomotive in 1946. The crews who drove the T1 in those first months talked about the experience with a kind of reverence. The locomotive felt alive under your hands in a way that other machines did not. It responded instantly to the throttle, built power smoothly rather than in lurching increments, and at high speed, moved with a stability that defied the expectations of men who had spent careers wrestling with lesser machines through vibrations and jolts and the constant mechanical complaint that characterized so many steam designs. At 100 miles per hour, the T1 felt, in the words of one engineer who drove it repeatedly, like riding inside something that had been designed by God on a very good day. Encouraged by the test results, the Pennsylvania Railroad placed an order for 50 additional T1 locomotives, an enormous commitment, an expression of absolute confidence in the design's potential. Those 50 locomotives entered service between 1945 and 1946, spreading out across the main line between New York and Chicago, taking over the premier passenger runs. The Broadway Limited, the General, the Spirit of St. Louis, America's most celebrated trains, pulled by America's most celebrated locomotive. For a brief, brilliant period, the dream seemed to be working. Then the wheel slip began. It started as an occasional problem, a momentary loss of traction on a slippery section of track, an uncontrollable spinning of the driving wheels that lasted a few seconds before the crew managed to restore control. Annoying, but not alarming. Steam locomotives slipped sometimes. It was a known hazard, managed through experience and throttle technique. But the T1 slipping was different. It was more frequent, more violent, and far harder to control than anything the engineers had encountered before. The duplex drive, which had seemed like such a brilliant solution to the problem of distributing power, had created a new problem that nobody had fully anticipated. A conventional locomotive with a single driving system would slip and then catch. A single sharp event that the crew could manage with a quick adjustment of the throttle and the sander that sprinkled fine sand onto the rails to improve grip. A T1, with its two separate driving systems on the same rigid frame, could enter a condition where both systems were slipping simultaneously, reinforcing each other's loss of traction in a cascading failure that was almost impossible to interrupt. When a T1 slipped badly, it did not merely lose traction, it became a different machine entirely. The driving wheels, spinning freely without the load of the train to anchor them, accelerated instantly to terrifying speeds. The connecting rods, designed to operate at controlled velocities, began to flail in great wild arcs. The locomotive shook as if it were trying to tear itself apart. The noise was indescribable, a hammering, clattering roar that shook the ground and sent the crew diving for handholds. Men who experienced a bad T1 slip said afterward that they genuinely did not know, in the first few seconds, whether the locomotive was going to destroy itself or simply kill them outright. The slipping was worst at low speeds, precisely the conditions where the locomotive spent much of its time, starting from rest in a station, pulling away from a slow approach through a junction, climbing a grade at reduced speed, all the moments that were part of every single run, multiple times per trip. And the slipping was worst in wet weather, which in the eastern United States meant roughly a third of all operating days throughout the year. Drivers developed techniques for managing the problem. Delicate throttle work, opening the steam valve in careful increments rather than with the confident authority that the locomotive's power seemed to invite. Constant attention to the sanders, preemptively coating the rails with grit before any moment that might trigger a slip. An almost hypnotic awareness of the locomotive's feel through the controls, the tiny preliminary vibrations that preceded a full slip if you knew how to read them. These techniques worked. Experienced T1 crews could keep a locomotive under control through conditions that would have made a less skilled operator give up. But they required a level of concentration and expertise that was exhausting to sustain across a full shift, and they depended on experience that had to be earned the hard way, through enough frightening near misses to develop an instinctive feel for the machine's moods. And no technique worked all the time. On some days, on some tracks, in some weather conditions, the T1 would slip no matter what you did. It would slip repeatedly. It would slip when you least expected it. It would slip at speeds and in conditions where slipping should have been impossible. The Pennsylvania Railroad's engineering teams attacked the problem with everything they had. They modified the valve gear, adjusting the timing of the steam admission to each cylinder in an attempt to even out the power impulses and reduce the tendency toward wheel spin. They experimented with different wheel profiles, trying to find a contact geometry that would provide better adhesion. They changed the weight distribution of the locomotive, adding and subtracting ballast from different locations to alter the load on each driving axle. They tested different sand application systems, different rail treatments, different throttle control mechanisms. Every modification helped a little. None of them solved the fundamental problem. The duplex drive distributed power beautifully in theory. In practice, it distributed the potential for slip just as effectively as it distributed traction. When conditions were right, the T1 was magnificent. When conditions were wrong, it was a dangerous and infuriating beast. While the Pennsylvania Railroad's engineers struggled with the wheel slip problem, a more fundamental threat was developing that had nothing to do with traction at all. The Electromotive division of General Motors had spent the war years developing its diesel-electric locomotives to a level of reliability and refinement that was beginning to make steam comparisons look not just unfavorable, but almost absurd. The EMD locomotives were not as fast as the T1 at its best. They were not as powerful in peak output. They could not hit 112 miles per hour under any conditions, and nobody who worked with them claimed otherwise. But they were available. Every morning, reliably, without exception, they were ready to run. They did not need the 45-minute warm-up period that steam required. They did not need a skilled fireman maintaining boiler pressure throughout every shift. They did not need the army of specialized maintenance workers that steam demanded. A diesel locomotive could be inspected, fueled, and in service within minutes of arriving at a terminal. A steam locomotive required a small ceremony before it could move. The diesel burned fuel more efficiently at moderate speeds. Not at the extreme speeds where the T1 excelled, but at the moderate speeds where most trains actually operated most of the time. An EMD diesel cruising at 80 miles per hour was burning a fraction of what a T1 burned at the same speed, without the water consumption that made steam operations dependent on infrastructure. The water towers, the treatment plants, the chemical systems required to prevent scale buildup in boilers, spread across thousands of miles of track. Railroad accountants, unlike locomotive designers, do not care about peak performance. They care about cost per ton mile, about maintenance expenses, about the ratio between time in service and time in the shop. By every metric that accountants measure, the diesel was destroying steam in comparisons that became less flattering to steam with every passing quarter. The Pennsylvania Railroad knew this. Their own internal analysis showed it, and yet they had just committed to 50 T1 locomotives at enormous expense, and the company's identity was bound up in its reputation for engineering excellence in steam. Admitting that the T1 was not the answer was not merely a technical acknowledgement, it was an institutional surrender. So they kept running the T1, kept trying to fix the slip problem, kept producing optimistic reports about modifications that were going to solve everything, while the Electromotive division's sales force worked through the railroad industry with quiet, relentless efficiency, signing contract after contract for the machines that were going to replace everything else. Inside the shops, the T1's maintenance demands were becoming the second major crisis alongside the wheel slip. The duplex drive was elegant in concept but complicated in practice. The two separate cylinder assemblies, each with its own valve gear and steam distribution system, created twice as many points of potential failure. Adjustments that needed to be made to one set of cylinders often had to be replicated on the other, doubling the labor time. The smooth external shroud that made the T1 so visually stunning made access to the machinery extraordinarily difficult. Work that took minutes on a conventional locomotive could take hours on a T1, with mechanics contorting themselves into spaces that had been designed for aerodynamics rather than human access. The boiler, pushed to deliver the extreme steam output that the duplex drive demanded, required more frequent inspection and more aggressive maintenance than standard designs. The firebox, optimized for the kind of intense combustion that could sustain high speeds over long distances, needed constant attention from maintenance crews who had been trained on different equipment and had to develop new skills almost entirely on the job. The maintenance records from the Pennsylvania Railroad's shops in those years read like a chronicle of quiet desperation. Locomotives coming in with damaged valve gear. Locomotives returning from service with crankpin wear that should not have been possible after the number of miles logged. Mechanics writing reports in the careful, professional language of men who have learned that honesty about equipment problems is dangerous to careers, but who cannot quite conceal the exhaustion and frustration underneath the technical language. One locomotive, according to internal records from 1948, spent more days in the shop during its first year of operation than it spent in revenue service, more days standing still with its skin opened up and mechanics crawling through it than it spent doing the work it had been built to do. That was not exceptional, that was close to average. The T1 was magnificent when it ran. It ran perhaps 60% of the days it was supposed to run. The other 40%, it was being repaired, modified, inspected, or waiting for parts that were hard to get because nothing else used components quite like these. The end did not come with a single dramatic event. There was no spectacular failure, no catastrophic crash that ended the program overnight. The T1 died the slow death of an idea that cannot sustain itself against the weight of accumulated evidence. Through 1948 and 1949, the Pennsylvania Railroad began quietly reassigning the T1 to secondary duties. The premier runs, the ones that absolutely could not afford delays, began to see more diesel power. The T1 was shifted to routes where its speed was less critical, where a slip or an unplanned stop was a frustration rather than a disaster. The engineers who had designed the T1, who had staked their professional reputations on its success, were no longer writing optimistic reports about upcoming modifications. They were writing reports with the flat, exhausted tone of men who had run out of ideas and were beginning to face what they had known for some time but had refused to say aloud. The duplex drive was not going to be made reliable enough to justify the maintenance costs. The wheel slip was not going to be solved with the tools available. The diesel was not a passing trend or a niche solution. It was the future, and the future had arrived on schedule while everyone was busy trying to fix the T1's valve gear. In 1949, the Pennsylvania Railroad placed its first major order for diesel locomotives to replace steam on the main passenger lines. The T1 locomotives, the pride of the company, the embodiment of $1 billion worth of confidence in the future of steam, were reclassified as surplus. The scrapping began in 1952. It proceeded with efficient, business-like speed. The locomotives that had been built to last 30 years were torn apart after 5. The beautiful shrouding that Raymond Loewy had designed was cut away with torches and sent to the smelter. The massive boilers, each representing hundreds of hours of skilled labor, were reduced to raw steel. The duplex drive mechanisms, which had occupied some of the most talented engineering minds in America for nearly a decade, were disassembled and melted down. By 1956, the last T1 was gone. Not one was preserved. In an era when railroad preservation was still a young and poorly organized movement, when the value of saving historic equipment was not as clearly understood as it would become in later decades, nobody stepped forward in time to rescue even a single example of the most powerful, fastest, most visually extraordinary steam locomotive America ever built. The Pennsylvania Railroad, which had been so proud of its T1 that it displayed one at the 1939 World's Fair, could not move quickly enough to save any of them when the decision was made to end the program. They were simply gone. What remained was the question that historians and enthusiasts have debated ever since. Why? How did something so capable fail so completely? The answer is complicated, and it contains lessons that extend far beyond the specific engineering problems of the duplex drive. The T1 was designed to win a race that was already over before the first locomotive was delivered. The Pennsylvania Railroad's engineers saw the diesel threat clearly. They understood that steam had to improve dramatically to compete. They set out to produce a locomotive so far ahead of anything diesel could offer that the comparison would be impossible to dispute, and they largely succeeded at that specific goal. The T1 was faster than any diesel in service in the 1940s. It was more powerful in peak output. On its best days, operated by its best crews in optimal conditions, it was exactly what they had promised it would be. But winning a race to peak performance was never the question. The question was which technology could deliver reliable, cost-effective service across thousands of miles of track, operated by thousands of different crew members, maintained by mechanics in dozens of different shops, through every kind of weather and every kind of operating condition. The question was not which locomotive was most magnificent. The question was which locomotive would still be running next Tuesday and the Tuesday after that, without drama, without incident, without costing more to keep alive than the revenue it generated. In that competition, the T1 never had a chance, not because it was badly designed, but because it was designed to answer the wrong question. A team of brilliant engineers, given the freedom and resources of the world's most powerful railroad, had produced a machine that defined the absolute outer boundary of what steam could achieve, and in doing so, they had proved that the outer boundary of what steam could achieve was not sufficient for the world that was coming. Every modification they made to improve reliability came at the cost of something else: performance, maintainability, or the careful balance of forces that made the duplex drive work at all when it worked. There was no configuration of the T1 that was both fast enough to justify its existence and reliable enough to operate economically. The design existed in a narrow corridor between capability and practicality, and the corridor was too narrow to build a railroad on. The men who designed the diesel locomotives that replaced the T1 were not more talented. They were not more creative. They were solving a different problem with different constraints, and those constraints happened to align with what the railroad industry actually needed in the second half of the 20th century. Simplicity over brilliance, reliability over magnificence. The machine that was there every morning over the machine that was extraordinary when it ran. Today, the T1 exists only in photographs, in film, and in the extraordinary efforts of the T1 Trust, a group of engineers and enthusiasts who have spent years attempting to build a new T1 from scratch, working from original drawings, applying modern metallurgical knowledge and manufacturing techniques to the 100-year-old design, trying to produce the locomotive that was promised and never quite delivered. Their project, if it succeeds, will be one of the most remarkable achievements in the history of locomotive restoration. Whether it will also solve the wheel slip problem that defeated the original designers remains to be seen. But there is something worth reflecting on in the effort itself. The T1 was scrapped in such haste, discarded so completely, that not even a single example was preserved for the museums that would eventually want to show it. The organization that built it could not imagine, in the early 1950s, that people decades later would look at the photographs and feel something like grief. Could not imagine that the speed and power and beauty would outlast the operating economics in the cultural memory of the people who cared about these things. The Pennsylvania Railroad, in its final years before it merged with its great rival into a company that would collapse into bankruptcy, sold its T1 locomotives for scrap at something like 30 cents per pound. The metal that had been shaped into the most beautiful machine in American railroad history was melted back to raw material and used for other purposes: kitchen appliances, building frames, perhaps parts of the very diesel locomotives that replaced it. There are photographs from those years of T1 locomotives lined up in scrapyards, their distinctive shark-nosed shrouding already cut away, their innards exposed to the weather, waiting for the torch. There is something in those photographs that is hard to look at directly. Not because locomotives are more important than the people who operate them, or because the failure of a design program is a tragedy in any human sense, but because there is something deeply melancholy about a thing made with such ambition and such skill, designed to embody an entire civilization's confidence in its own engineering mastery, reduced so quickly and so completely to raw material. The men who had driven T1 locomotives at 112 miles per hour, who had coaxed them through the wheel slip and nursed them through their maintenance crises, who had learned to read their moods and hear their warnings in the sound of metal and steam, those men had to stand and watch the machines they had mastered turned into scrap. Some of them drove the diesel locomotives that replaced the T1. They said the diesel was easier, more predictable, more comfortable to operate. They said it almost never surprised you. None of them said it was the same thing. The T1 sits at a strange intersection of railroad history. It is too extraordinary to be forgotten, and too failed to be fully celebrated. It is remembered by enthusiasts with a passion that far exceeds what its commercial record would seem to justify. Its speed records still impress. Its design still stops people cold in photographs. The story of its creation and destruction still provokes arguments about whether different choices could have saved it, whether a better solution to the wheel slip existed, whether the Pennsylvania Railroad gave up too soon or held on too long. These arguments will never be resolved. The evidence is gone, scrapped along with the locomotives themselves. What can be said with certainty is that the T1 represents something that happens periodically throughout the history of technology. A moment when the best practitioners of an existing method push it to its absolute limit in a final, magnificent, doomed attempt to compete with something fundamentally different. The T1 was steam at its apex, steam at its most powerful and its most beautiful and its most ambitious. An apex is another word for the moment just before the fall. The diesel locomotives that replaced the T1 were never as fast, never as beautiful, never as stirring to watch at speed or as haunting in their sound. The diesels were practical and reliable and economical and utterly, completely ordinary. The diesels won, and the most beautiful machine America ever put on rails was melted into scrap before anyone thought to save even one. There are places along the old Pennsylvania Railroad main line where, if you stand on a clear day and listen past the sound of traffic and wind, the older residents will tell you that some days they can almost hear something in the distance. A rhythm in the rails, a vibration in the ground, the ghost of a sound that belongs to something enormous moving very fast. They know it is not real. The T1 is gone. All 50 of them are gone. But some ghosts are too magnificent to stay quiet, even after everything that made them possible has been melted back into the world and forgotten. The most beautiful locomotive ever built is still out there somewhere, in photographs, in drawings, in the memories of people who saw it run, and perhaps in the bones of the earth itself, where 50 years of thunder at 100 miles per hour left marks that outlasted the machines. It was built to save an era. It proved instead that some eras cannot be saved, and in proving it so magnificently, so completely, and so finally, it became immortal in the only way that failed ambitions ever become immortal. Not by succeeding, but by being too extraordinary to forget, even after everything about it has been destroyed.